So this is the main dashboard of the pre-security AI native SecOps platform. Before I go into the demo, let me tell you a little bit about how the product actually operates. This is the first security product in the industry that does predictive analytics using generative AI powered by large language models as well as GPUs. So what I'm going to work you through first is kind of the workflow that our system uses to process data in order to make generative AI detections and generative AI predictions. Before we even start thinking about doing detections and predictions and things like that, we need to make sure that we get quality data into the system. Because if you don't get quality data into the system, you end up having a garbage in, garbage out problem. So over here on the left-hand side of the user interface is where our data collection process begins. The first thing that we need to do is make sure that we can get data into the system. We have a log receiver that can receive data from any data source of any kind. The data can come from a variety of different tools. They could be firewall tools, endpoint security tools, or even server logs themselves. So in order to get data into our system, the only thing you really need to do is set up what's called a log receiver. So you set up a log receiver and you configure a protocol and a port where you want the data to come into. And after you do that, you're pretty much done. There's no need to create parsers to parse data from various types of firewalls or endpoints or anything like that. The system automatically will parse the data for you. Once the data comes into the system and it's been ingested, it's really important that you start to configure filter rules, because not all data is actually useful data when making detections or predictions. Many times you'll have server logs that'll come in that are simply heartbeat logs. Maybe every 60 seconds, a log comes in saying that the server is alive, And sometimes you'll have millions of logs like that. It doesn't really make sense to process logs that will not have any way of being used for detections or predictions. So you need to filter data out. Our system also can deduplicate data. Sometimes you'll have 2 or 3 logs coming in from different sources, and it doesn't make sense to have 2 or 3 or 4 of the same log. So here's where you configure filtering and deduplication. The next important thing that we want to do when we're processing data is to classify data. Not all logs are created equal. Some logs are of high value and some logs are of low value. So this is the area of our system where you can configure the value for logs. And high value logs will be processed before low value logs. Again, I use the analogy of server heartbeat logs. Those would be considered low value logs. But if it's a firewall block log, for example, that would be considered a high value log. So we're prioritizing logs. We also have multiple ways of getting data into the system. Our system can receive data via logs coming in. Maybe it's syslog being streamed into the platform, or our system can actually reach out and connect to one of your tools using APIs to pull that data out. And we call those things data connectors. You can configure those things here. The other thing that's really important too is when you're setting up the system, you also need to understand that the system uses a large language model that's been trained on cybersecurity data. We call that our Cyber LLM. That's a proprietary large language model trained specifically on cybersecurity content. And it uses that for detections and predictions. But we also give our customers the ability to train the model themselves. And this is called our reference knowledge base. Simply, you can come here and upload content. For example, you might want to have a PCI compliance document or some other regulatory document, maybe that's specific to the organization or the country where you're deploying the solution. You would simply upload that document here. And once you've done that, you've trained the large language model on data that's specific to you in your environment. And that data will be used going forward to make detections and predictions. You can also set up rules. In the legacy world, rules were defined by static things. If you see this in a log and you see this other component in a log, then that equals this type of detection. In our world, we're trying to eliminate manually created logs and parsers and things like that. We've done the same thing when it comes to security rules. So security rules in our world are natural language created rules. I'll give you an example. Here's a rule that we created. It's called the CEO risk rule. I give the rule a name, CEO risk rule. I tell it who it's applied to. It's applied to a username versus an IP address or URL. And I tell it what the value is. In this case, the value is John Peterson, the CEO. And when I create a rule, I can simply create a natural language rule. It's not a rule based on keys and values and field and values and things like that. It's simply, if you can describe it, it becomes a rule. So let me read you this example. If the username John Peterson is seen in a security log, increase the risk by 35% because he is the CEO and has access to critical data. It's simple as that, and you save the rule. So now when data starts processing through our system, the large language model knows that John Peterson is the CEO, and anytime you see his username in a log, change the risk score and increase it by 35%. The system also has built-in Sigma rules. Sigma rules are commonly seen in the cybersecurity industry. They're created by security professionals all over the world, and our system is also trained on Sigma rules. It constantly updates itself and trains itself. So not only do you have a cyber LLM that's been trained by pre-security, you also have the ability to train it yourself. There's also built-in threat intelligence feeds that indicate what are known good and known bad URLs, IP addresses, domain names, and things like that. So the data configuration is the first place you start when you use our system. Make sure it's set up properly, otherwise you'll have a garbage in, garbage out scenario, and your detections and predictions will not be of high fidelity. So the next thing we'll talk about is observations. We have a SIEM that's built into our platform, but our SIEM is not just any normal SIEM. Our SIEM is powered by generative AI, again, powered by our large language model called Cyber LLM, which is ultimately processed by GPUs. So in our world, a SIEM brings in these raw logs, and it's a little bit different because when data comes into our system and gets processed by the GPU, one of the really unique things that we do is something that we call log to NLP. It's the process of converting a raw log that may be in JSON format or syslog format to natural language. Let me give you an example. This is actually a log here that's been processed, auto-parsed by our large language model. And if you look at the raw log, you see this log here that's in JSON format. Now, to a skilled security analyst, they might be able to look at this and interpret it and understand it. But maybe for a junior SOC analyst, it'll be a little bit difficult for them to understand all these different fields and values. So what our system does is it converts that raw log to something called a natural language representation of the log. And you'll see here it's labeled NLP text, and you can simply read this. Now, this NLP text or representation of the raw log happens to be in English, but it can also output this in Japanese. One of the other things that our SIEM does is it assigns risk scores. Traditionally, risk score calculations were done by a vendor's static algorithm that determines risk. In our world, risk scores are not statically created by some algorithm. It's dynamically generated by our large language model. And that is done based on the knowledge that the large language model has, either because of how we trained it or because of the reference data that you've given it to train it yourself. So you'll notice here there's a risk score column with a variety of different risk calculations. And we also have the ability to search these logs, not using static queries that you might use on a SIEM tool. Our queries are done in natural language. We call this functionality Search GPT. So let's say I want to do a search here for all logs that have a risk score greater than 80%. I just simply type it in. Give me a list of all security alerts with a risk score greater than 80%. Now notice that the risk score column will change once I do this search. And there you go. It's now given me only the logs that have a risk score greater than 80%. This is a natural language search versus a traditional query search. So these are things that we call observations, simply alerts and things like that that are coming from a variety of different tools. And then we move on to the next step of our processing, which is to take those observations and then do a generative AI contextual detection. Let's take a look at an example. Here's a case where I've got a log. I'm just going to click the triage button. And what happens here is the system will start to take logs that are related to a specific entity. Let's say that it's a server. In this case, I've got 15 logs that the server has seen over the last 24 hours. Our system will determine that, bring all of those logs together and correlate them and send all 15 logs to our detection processors. And we end up with a contextual detected event. And in this example, it's saying that SQL injection attempt was detected. But it's not a SQL injection attempt for each of the 15 logs. Each log tells its own separate story. But when you put all 15 logs together, they start to tell a story like you would see in a book. I call this like a log book. So the log book consists of about 15 logs, and our large language model has been able to interpret what's really going on. Instead of having to chase down every single alert individually, we bring all of those alerts together and we consolidate that down into a single contextual alert. It not only does that, it also gives you a summary of what's going on in natural language, as well as a detailed analysis and a recommendation on what you should do. Once detections are done, the next stage of the process is predictions, which I believe is kind of the most important thing in the process. Most security tools are detection oriented, which means it's telling you something after it's already happened. In our world, we think that a better approach is to predict something before it happens and then get ahead of the problem and mitigate it from happening in the first place. So again, predictions I think are more important. Let me give you an example of a predicted event. Here's a prediction. We call this a consensus predicted event. And in a moment, I'll explain to you what consensus predicted means. But we have a SQL injection attack that has been predicted. It has not occurred yet, has not happened yet, but there's a prediction saying that has a high probability of it occurring. And if it does occur, it will pose a risk of 21% to your environment. And this prediction was created by correlating 14 logs from a particular asset in the environment. It gives you an explanation of why it came up with the prediction, a summary of what it means, a detailed analysis, and a recommendation. Here, at the bottom, there are 4 different prediction engines that are running on the data set. And each prediction looks at the data from a different point of view. We have a Markov model point of view, a MITRE ATT&CK framework point of view, and a Lockheed Martin framework point of view, and a SOC analyst point of view, or simply how would a human interpret this data? And what we do is we take these 4 different predictions from 4 different points of view and we bring them all together to get a consensus. It's very similar to going to a doctor, getting a diagnosis, and then going to a second doctor, a third doctor, a fourth doctor to get 4 different opinions such that you can end up with a consensus. And that's what we call a consensus predicted event. After the system's kind of processed the data, done detections on the data, made predictions on the data, we give our users the ability to interact with the data using natural language. And I'm going to give you an example. This is what we call SOC GPT. Think of it kind of like ChatGPT, but based on your security data and based on the training of a security large language model. So the first thing I'm going to do is I'm going to tell the system to talk to me in Japanese. Please respond to my questions in Japanese. Hello, how are you? Now I'm going to say, give me a list of the top 5 security alerts in my environment from this week, and respond in Japanese. And there you go. The system has knowledge of all of your logs, all of your data. It's been trained on cybersecurity information, and you can simply go ahead and talk to your data and get back the answers you want. I can even tell the system to respond with the data in a different type of format. Please respond again with this data, but in a table format, and respond in Japanese. And there you have it. There's many ways to use the system, and there's a lot of different ways you can ask questions about your data. If there's something in your logs that you don't understand, you can simply ask it a question and say, please explain to me what this means. And that's a kind of a summary of our system and how our product operates. Hopefully that was helpful.